Hello, this is Yashvin. In this video, I'll be solving paper 4 variant 2, May June 2018, Chemistry 0620. Starting with question number 1. Give the name of the process that is used A to obtain water from aqueous sodium chloride. Since there is a huge difference between the boiling points of water and sodium chloride, this time it's going to be only distillation and not fractional distillation. B. To produce lead from molten lead bromide. This is going to be electrolysis, since this is separation of an ion of ions from the ionic compound. C. To separate an insoluble solid from a liquid, which is quite simple. It's filtration. D. To produce the components of petroleum. So this is based on the difference in boiling points, which are relatively closer. So the answer is fractional distillation. E. To separate a mixture of colored dyes is chromatography. 2. This question is about the elements in period 3 of the periodic table. For each of the following, identify a period 3 element which matches the description. Each element may be used once, more than once, or not at all. State which period 3 element A forms an oxide with a macromolecular structure. And here we have silicon, which forms a macromolecular structure. B is extracted from the ore oxide, which is aluminum. C is a soft metallic and stored in oil. This is sodium, which is soft. D is a green gas at room temperature and pressure. So we have chlorine over here. E provides an inert atmosphere in lamps. This is going to be argon. F forms two different oxides in the contact process, which is basically sulfur. Sulfur is involved in contact process, forms sulfur dye and dioxide. G is non-metallic and an important component of fertilizers. So this is phosphorus. 3. Complete the following table. Right, so we have protons, electrons, neutrons, and the symbol. Alright, so the number of neutrons is atomic number subtracted from the mass number over here. So sodium, for sodium, that is 23 minus 11, which is 12. And then we have the chloride ions. But the number of protons is equal to the atomic number, which is 17. And since this has a charge of -1, that means this chloride ion has one extra electron, which gives it the number of electrons 18. Number of nucleons again is 17 minus 37, which is 20. Now we have an ion, since as you can see over here the number of protons is 26 and electrons is 24. That means it is a cation or an ion with a positive charge of 2, because the difference over here is 2, and the element with a proton number 26 is iron, but I'm going to be writing it in the form of ion, and that is quite necessary that you write the ion oxidation state and not just the element symbol. 4. Potassium reacts with bromine at room temperature to form potassium bromide. A. Write a chemical equation for this reaction. Include state symbols. Alright. So potassium is a solid which reacts with bromine, which is liquid at room temperature and pressure. This is L over here, and forms potassium bromide, which is again a solid. Now for balancing the equation, we have 2 potassium atoms to balance out the number of electrons on the product side. B. Potassium bromide exists as an ionic lattice. Potassium bromide does not conduct electricity when solid but does conduct electricity when molten. 1. What is meant by the term ionic lattice? Alright, so you're supposed to be writing the definition of an ionic lattice, which is And that's it. 2. Explain why potassium bromide does not conduct electricity when solid but does conduct electricity when molten. So for electricity to be conducted, the ions in this ionic compound have to be able to move throughout the structure and conduct electricity, which they can't in solid form, but in molten or aqueous form they can move and conduct electricity. C. Concentrated aqueous potassium bromide is an electrolyte. 1. What is meant by the term electrolyte? So it's basically the substance for which the electrolysis process is run. So you write the definition of the term electrolyte, the proper definition. To describe the electrolysis of concentrated aqueous potassium bromide. Right. So what I would like to do in electrolysis questions is I like to break down the ions of the ionic compounds, as well as if we have in the aqueous form. So I like to break down all of the ions present in the electrolyte. So first off, we have the water ions, or hydrogen and hydroxide ions. And then we have potassium bromide, potassium, the metal, which is cation, and the negative ion, which is the bromide ion. Include an ionic half equation for the reaction at the cathode. Cathode is the negative electrode, and that means it would attract positive ions, which are hydrogen and potassium ions over here. And if the more reactive of the two positive ions stays as the ion itself, and the less reactive of the two positive ions is discharged. And so that means since hydrogen is less reactive than potassium, in this case, hydrogen is going to be discharged at cathode. So it has the ionic equation, the ion hydrogen. As you can see over here, it has an oxidation state of +1, or in other words, it needs one electron to cancel out this positive charge, since in ionic equations, we're supposed to be canceling out the charge. So you can do this either by adding or removing electrons. So in here, we need to add electrons to cancel out the +1 charge. And since the charge is only 1, we add only one electron for each hydrogen ion, and this forms a hydrogen atom. But since hydrogen exists in its diatomic molecule form, we need to have hydrogen molecule on the product side, and for this same reason, we need to have two hydrogen ions to start with, and that means a total of 2 plus charge, which would mean adding 2 ions to neutralize them, or to cancel out the charge, not neutralize. The name of the product at the anode. Right, anode is the positive electrode, which means it would attract the negative ions. Now, which ion is going to be discharged? For negative ions, the scenario is going to be opposite. The more reactive of the two negative ions is going to be charged at the anode, and since bromine is more reactive than hydroxide ion, it is going to be discharged in this case. So bromide ions are discharged to form bromine, the name of the potassium compound form. So we're left behind with potassium and hydroxide in the solution, which forms potassium hydroxide. 3. When molten potassium bromide is electrolyzed, the product at the cathode is different. Name the product at the cathode when molten potassium bromide is electrolyzed. Alright, so cathode, being the negative electrode, attracts the positive ions. So in this case, when it's molten, there are no hydrogen ions. There is no choice for the potassium ions to be there. They are always going to be discharged at the cathode when there are no hydrogen ions, since they are the only positive ions or cations. D. Iodine reacts with chlorine to form iodine monochloride. As the only product, write a chemical equation for the reaction. to draw a dot and cross diagram to show the electron arrangement in a molecule of iodine monochloride. Show outer shell electrons only. Right, so iodine and chlorine, both from group 7, have 7 electrons, and they both need only 1 electron to complete the outer shell, and that means they are both going to share one of their electrons to complete that shell. So I have X representing chlorine over here, and the dot representing iodine electrons. E. Potassium bromide has a melting point of 734 degrees Celsius. Iodine monochloride has a melting point of 27 degrees Celsius. In terms of attractive forces, explain why there's a large difference between these melting points. Right. I'd like to discuss the melting process over here a bit. So as you can see, iodine monochloride is a covalent compound. So during the melting process, what happens is the molecules are, say this is one molecule, this circle represents one molecule of iodine monochloride in the solid form. Now, to break it down or to separate these molecules to form liquid, there are forces between all of these molecules, iodine molecules, which need to be broken. And when those forces are broken, the molecules are free to move past each other and form liquid. Now, because these forces between molecules are weak, not a lot of energy is required to break them, and so the melting point is low. However, for potassium bromide, this is an ionic compound, which means it has an ionic lattice, and for the melting of an ionic compound, the ions themselves are supposed to be separated, which requires a lot of energy than just breaking bonds between molecules. So that is why there's a huge gap between the melting points of covalent compounds and ionic compounds. So the forces which hold together these molecules are called intermolecular forces, since these are the forces between molecules. Some students might mistake these intermolecular forces with covalent bonds. So instead of writing, they might write weak covalent bonds, which is not true at all. Because for melting, you're not breaking down the molecules, you're only separating them. Because if you break down the covalent bonds, you'd be breaking down this entire molecule into iodine and chlorine, which is not happening. You're just separating these tightly packed molecules. So you only need to break the intermolecular forces and not the covalent bonds within the molecules. F. When chlorine gas is passed through aqueous potassium bromide, a redox reaction occurs. The equation is shown. 1. Write an ionic half equation showing what happens to the chlorine molecules in this reaction. Right. So first off, we start with the chlorine diatomic molecules, and as you can see over here, it forms 2 chloride ions. Now here the oxidation state of chlorine is 0, or in other words, it is a neutral molecules, and for it to gain a charge of 2 negative, and I'm saying 2 negative because there are 2 chloride ions each having -1 charge, that means the two have 2 negative charge. So for the oxidation state to become from 0 to 2 negative, you need to add 2 electrons. So what happens over here is you add 2 electrons to form 2 chloride ions. To explain why the bromide ions act as reducing agents in this reaction, because they are oxidized in this reaction. 5. Hydrogen and iodine react together in a reversible reaction. Hydrogen iodide is formed. The forward reaction is exothermic. A gas syringe containing an equilibrium mixture of hydrogen, iodine, and hydrogen iodide gases was sealed and heated to 250 degrees Celsius. The equilibrium mixture was a pale purple color. A. What is meant by the term equilibrium? So start by writing the definition of equilibrium. Since the rate of forward reaction and backward reactions are the same, concentration of products and reactants remains the same. B. The plunger of the gas syringe was pressed in while the end of the gas syringe was blocked. This increased the pressure. The position of the equilibrium did not change. The color of the gaseous mixture turned darker purple. 1. Give a reason why the position of the equilibrium did not change. Right. The position of the equilibrium might have changed if the number of moles or number of molecules on the two sides was different. But as you can see over here, we have one hydrogen molecule, one iodine molecule. So in total, we have two molecules. And on the product side, similarly, we have two molecules as well. And that means increasing the pressure increases the collisions on both sides equally. Right. So that means there is no net change in equilibrium. So that means position of the equilibrium does not change. To suggest why the gaseous mixture turned darker purple even though the position of the equilibrium did not change, that's just because the molecules of iodine have come closer together. C. The temperature of the gas syringe was increased to 300 degrees Celsius. 1. What happened to the position of the equilibrium when the temperature of the gas syringe was increased from 250 degrees Celsius to 300 degrees Celsius? Right. So as the question states, the forward reaction is exothermic, and that means increasing the temperature would favor the backward reaction, which is endothermic. In other words, equilibrium shifts to left. 2. What happened to the rate of forward reaction and the rate of backward reaction when the temperature of the gas syringe was increased from 250 degrees Celsius to 300 degrees Celsius? So the rate of both of the reactions increases because molecules on both sides gain energy. That means they collide faster, and as a result, they react faster, or the rate of reaction increases. 6a. All sodium salts are soluble in water. All nitrates are soluble in water. Barium carbonate is insoluble in water. Describe how you'd make a pure dry sample of barium carbonate by precipitation. Include the names of the starting materials. So that means to start with, you need to have two compounds which have barium and the carbonate ion. As you can see over here, sodium salts are soluble in water. That means this is a hint that you need to have a sodium salt in this reaction, which could be the starting material. And so we're going to be having a sodium carbonate as one of the starting materials. So the names of the starting materials are sodium carbonate, full practical details. Alright, so to form the precipitate, you first need to form solutions of the two salts and then mix them. And after you mix them, you'd get a precipitate of barium carbonate, which you then have to filter out from the solution mixture. Now, once you've collected the precipitate or the final product, you'd have to wash it and then dry it to remove any remaining reactants on the salt. A chemical equation. Alright, so we have the reactants as sodium carbonate as well as barium nitrate, forming barium carbonate. Right. B. Nitrates decompose when heated. 1. Write a chemical equation for the decomposition of sodium nitrate when it is heated. Since sodium is a reactive metal, its nitrate does not decompose typical method of other metals. It does not decompose completely. 2. The unbalanced chemical equation for the decomposition of hydrated copper nitrate crystals is shown. Balance the chemical equation for this reaction. So you have 2 copper atoms on the reactant side. That means you need to have 2 copper atoms on the product side as well. And then you have 3 twos are, no wait, you have 2 threes are 6 and 6 twos are 12, which means you have 12 hydrogen atoms, so you need to balance out the number. Alright, 6 over here, so we have 12 hydrogen atoms, and then the remaining are nitrogen atoms. Similarly, nitrogen atoms have 2 twos are 4, which means you write a 4 over here, and there you have your balanced equation. 3. When the hydrated copper nitrate crystals are heated, steam is produced. When the steam condenses on a cool surface, it turns into a colorless liquid. Anhydrous cobalt chloride is used to show that the colorless liquid contains water. How does the color of the anhydrous cobalt chloride changes? So it changes from blue to pink. 4. How would the student test to determine if the water produced in B part 3 is pure? So to test the purity of any substance, you could always check its melting point. If it is a sharp straight melting point, it's not over a range of temperatures, it is a pure substance. 7. Many organic compounds such as alcohols, carboxylic acids, and esters contain the elements carbon, hydrogen, and oxygen only. A compound R has the following composition by mass. So you have carbon, hydrogen, and oxygen. Calculate the empirical formula of compound R. So you start with writing the symbols of all of the elements. Then you write the percentage composition and calculate the moles using composition percentage. So divide this by the atomic mass, which is 12 in case of carbon and 1 in case of hydrogen, 16 in case of oxygen. And that leaves us with 5 and 13.33, 1.67. So you calculate the ratio by dividing the least value, which in this case is 1.67, and you get the rounded figures as 3:8:1, which is carbon, hydrogen, and oxygen. That means you have C3H8 and O. B. Compound S has the empirical formula C2H4 and O and a relative molecular mass of 88. Calculate the molecular formula of compound S. So first off, you start with calculating the MR of the compound, which is you multiply the number of atoms of each element present in the compound with its mass. So we have 2 carbon atoms multiplied with its mass, which is 12. Then you add the rest of them. So this is equal to 44. Now you divide the figure given in the question, which is 88, with the value which we just calculated, and this gives the answer as 2. So you multiply 2 with all of the number of atoms over here. So you have 2 2s are 4 carbon atoms, 2 4s are 8, which means 8 hydrogen atoms, and 2 1s are 2, which is 2 oxygen atoms. See, compound T and V both have the molecular formula C3H6O2. Compound T produces bubbles of carbon dioxide gas when it is added to aqueous sodium carbonate. So when T reacts with a carbonate, it produces carbon dioxide, which means T must be an acid. Compound V is an ester. 1. What is the name given to the compounds with the same molecular formula but different structural formula? These are structural isomers. 2. Draw the structures of compounds T and V. Show all of the atoms and all of the bonds. Right. So as I discussed earlier, T must be an acid if it reacts with sodium carbonate and produces carbon dioxide. So first off, I'd start by drawing the acid group, which is C double bonded to oxygen, and then with hydroxide group as well. Now we have remaining 2 carbon atoms, and balance out their valencies. So we have the rest of the hydrogen atoms bonded to the carbons. Compound V is an ester. That means it would have the functional group, or the main structure as carbon double bonded to oxygen and single bonded with oxygen. Now we'd have the rest of the structure. We have remaining 2 carbon atoms. They could both be on the right side, or you could have one of them on either sides. And then you fill out the hydrogen atoms. So there you have the ester. 3. All compounds with molecular formula C3H6O2 can undergo complete combustion in excess of oxygen. Complete the chemical equation for this reaction. Alright, so we have combustion, that means oxygen, and this forms carbon dioxide as well as water. Now balancing the equation, we must have 3 carbon atoms, since on the reactant side we have 3 of them. Now we need to balance out the hydrogen as well. Since this was 6 over here, we need to multiply 2 with 3, and now we have 3 2s are 6 plus 3, which is 9 oxygen atoms. So to balance this on this side, we have 3.5 into 2, which is equal to 9. The compound W has the molecular formula C2H6O. Compound W reacts when heated with ethanoic acid and a catalyst to produce a sweet-smelling liquid. This sweet-smelling liquid is an ester. 1. Give the name of homologous series to which compound W belongs. Right. So an ester forms when an acid reacts with an alcohol, which means W must be an alcohol. 2. Draw the structure of compound W. Show all of the atoms and all of the bonds. So we have 2 carbon atoms, an alcohol group, and then the rest of the hydrogen atoms. E. Alkanes and alkenes are both hydrocarbons. 1. What is meant by the term hydrocarbon? It is a compound with hydrogen and carbon atoms only. State the general formula of alkanes and alkenes. So you have CnH2n plus 2 for alkanes. And then alkenes are CnH2n. Ethanol can be produced from long chain alkenes. Ethanol can be produced from long chain alkenes as shown. Step 1 is the breakdown of a long chain alkane to ethene, and then the conversion of ethene to ethanol by hydration. Describe the 2-stage manufacture of ethanol from the long chain alkane octane. include the names of the types of chemical reactions that occur. So the two reactions which occur are, from step 1 you break down an alkane to a shorter alkene, which would be cracking, and then the step 2 is hydration, since you add water to convert ethene to ethanol. So the first step is cracking. The reaction equations. Alright. So you have octane being broken down to ethene, which is C2H4, and then fill up the remaining carbon and hydrogen atoms, which would be C6H14. This question is of 5 marks, so you need to write 5 points in total. So now we have step 2, which is hydration of ethene. The chemical equation of ethene, C2H4 plus water, gives ethanol, C2H5OH, and the reaction conditions. Hydration requires the presence of catalyst, which is phosphoric acid in this case. And you could write other conditions as the temperature and pressure, but since the question only requires 5 points, I'm only writing the catalyst over here. So this is it. Thank you for watching.